All right, so here's the algebraic test for symmetry. There's a way we can also check the graphs. I'll save that till the end because not everybody has a graphing calculator. All right, so here's what we're looking for. When it says yields an equivalent equation, that basically just means same as the original equation. All right, so it has symmetry with respect to the x-axis when we replace y with negative y and yields the original equation. Okay, those are things you might want to highlight or point out too. This is symmetry test for the x-axis. We replace y with negative y. For symmetry with the y-axis, we replace x with negative x, and we're looking for the original equation again. And then if it's symmetric to the origin, we replace x with negative x and y with negative y. We usually leave that one to the end because once you've done both of these, a lot of the algebra work is already done. Okay? And that kind of is the success criteria. Like I said, we're not going to really use the symmetry to graph the equation. If you want to add to that, you can say check your solution with a graphing calculator if possible, because I will show you that at the end. But our main focus is going to be these algebra steps first, okay? Okay, so here we go. Let's start with number 11. Let's just choose one of these. Let's just go in order. Let's go with the x-axis symmetry. So I'm going to label this x-axis. Okay, go ahead and write that down. All right, so to check for x-axis symmetry, I'm supposed to replace y with negative y. Okay, so I'm taking this y right here, and I'm just going to replace it with a negative y. Okay, nothing else changes. And then you just look to simplify. In this case, I can't really simplify it, but in the next step, you'll see when we plug in a negative x for x, I can cube it and do some things to it. But since I'm just plugging it in here for y, there's nothing to do. And then I analyze, is it the same as the original equation? Clearly it's not. So what we assume here, since it's not the same, as original, so it's not symmetric to the x-axis. Okay. All right, let's go on to y-axis symmetry. Okay, so now I got to replace x with negative x, is what it says in step 2 up there. So it's going to look like this. 5 times x cubed, but instead of x, I'm going to replace it with negative x. And then I've got another spot to plug it in. 2 spots. All right, now we just evaluate it. Negative x cubed means negative x times negative x times negative x. The result of that is negative x to the third power. Okay, I'm just going to order of operations, right? Negative x times negative x times negative x. It helps you to see it like that. That's what I just did. Now I should take negative 1 times the 5 to get negative 5x cubed for that first term. Okay, second term, negative, there's no exponent, really just 1, so I don't have to do anything with that. Negative 1 times this negative 4 is positive 4x. Okay, so there's kind of the results right here. Is that the same as the original? Not quite. These signs are opposite, right? Negative, and then that's one that's positive. So it's not symmetric to the y-axis either. So not symmetric because it's not the same. Okay, so let's move on to the last one, the origin. So for origin symmetry, we replace both variables, x and y, with a negative. And then we see how it shakes out. So I've got a negative in for y, which I guess you don't really need the parentheses, but I'm going to do it at every variable on this one. Okay, you don't need to reinvent the wheel. We just spent some time evaluating what that looks like on the right side. So I'm going to write that as negative 5x cubed plus 4x, and the left side is just negative y. Okay, now here's a trick to this one. You'll get used to it. I know it's the first time. All the signs are just opposite. Like that's positive, this is negative. Opposite sign, opposite sign. So it usually means the equation's equal. You know, let's just say I had a real basic one. 2x equals 10, right? Now you compare it to negative 2x equals negative 10. Aren't those equations going to give me the same result? They will. They're equal. Okay, so if everything's the same except all the signs are just opposite, we could do this. All right, let's just try multiplying by 1. When multiplying by negative 1, watch what happens. All right, all of this by negative 1. We get y equals 5x cubed minus 4x. There's nothing wrong with doing that math. As long as whatever you do to one side, you do the other. It's balanced. So I didn't cheat. I just changed the look of it. It is the same as the original. So this is the same as the original. Okay, so since it's the same as the original, we're going to say it is symmetric to the origin. It's a big problem, isn't it? Not going on. Now, I'm kind of going over the top on detail, writing phrases in here. As long as you're showing the substitution and then the simplifying and then make a conclusion, I'm happy. I'll be happy with that. You know, plug it in, get this, and then say yes or no, it's symmetric to whatever you're checking. Okay. All right, so let's try to organize it kind of the same. I want you to try it for 12. So I'll pause now and let you give this a shot. Here you go. If you're not quite done, we'll finish up together. X-axis, replace y with negative r. We should make it look like this. There is a difference between quantity negative y squared and just this, because this looks like you already squared it and you want a negative 1 out front. So put in parentheses when you're substituting things in, and that gives us positive y squared. This is the same as the original. Okay, so this has x-axis symmetry, or you can just say symmetric to x-axis. Any questions on that first part? All right, y-axis symmetry, we replace x with negative x. There's no exponent there, so not much to do. It just becomes negative x minus 1. It's not the same. If that negative multiplying by negative 1 threw you off and you wanted to check it, you could. If you multiply by negative 1, it's still not going to work because I'm going to have negative y squared x plus 1 and still not the same. Okay, not symmetric to the y-axis. In the origin, okay, combination of the two, this gives me positive y squared. So again, it's not the same. If you wanted to peek at what it looks like to divide or multiply by negative 1, it doesn't match up. So it only works for x-axis symmetry. Okay, but if you have a graphing calculator, you could check some of these. Let me go back to the first one and show you. And you can follow along if you want, but it's not required to know how to do this. Your y equals, hopefully in Algebra 2, you learned how to plug things in your y equals. So 5x math cubed, minus 4x. Usually zoom 6 is a good standard window to start in. And then you can check and see if you think it's symmetric. Now, if you have a hard time looking at a graph and telling if it's symmetric, you might not like this method. Remember, I told you if you can reflect it over the y-axis and then over the x, and you see it down there, then it's symmetric to the origin. That's what's happening here. Reflect it over both, and you see it. So that confirms what we got with the symmetric to the origin. Okay, 12 gets a little more complicated with taking the square root and doing the plus or minus. Since it's not required, I'm not going to spin our wheels on that right now, okay? All right, one more thing I want to cover here today. I want to introduce these circle problems. We'll keep these pretty straightforward today. Tomorrow they get a little bit tougher. Thursday we'll mainly just review and spend a little more time on the tougher circle problems, reviewing for our end of the week quiz. It will be Friday. Okay. All right, so this is called the standard form of the equation of a circle. You don't have to have it memorized. I'll provide it with you or for you on your quiz. Okay, so let's focus on the standard form right now. HK represents the center of the circle. R is going to be the radius of our circle. Okay, so let's look at the directions of this first one. Write the standard form of the equation of the circle with the given characteristics. I don't know if I deleted it on your directions or not. The second part, we're not going to write it in general form, so you can scribble that part off if you want, okay? Okay, so from this definition, center is H, K is going to be the Y value, okay? So H is here, K is there, the radius is 4. So if I'm going to write the standard form, I just have to insert those values in the right spot in those 3 spots, H, K, and R. So it's going to look like this. X minus H, quantity squared, plus Y minus K, quantity squared, equals the radius squared. Okay, and then we just clean it up and simplify it, and then that's it. Okay, when we subtract the negative, make it plus 3, and then we typically square that number if we can. Okay, think of the backwards approach of this as well, because that's what 15 and 16 are about. If they tell you to identify the center, notice how this is a plus 3, but the coordinate was really a negative 3. It's because of that minus definition. Okay, this looks like a minus 2, but the x-coordinate was positive 2. Okay, so a little rule when you're going backwards is whatever that sign is, you just kind of take the opposite of it if you don't want to take the time to write it like that. Okay, let's wait on 14. That one's a little more difficult, but let's jump down to 15 in there. Yeah, 15 and 16. I'll help you through 15, and then 16 will be on you. This one now flips it. Now they're giving us the standard form of the circle, and we need to identify the center, radius, and then once we have that, we can definitely sketch the circle. Okay, so here's this first step I think you should do, just to help you see it. It's not in standard form yet, but a couple changes and we can put it in standard form. All right, when there's no number in there, it's just y squared. We could express that as y minus 0 quantity squared. That's the same thing. And then that helps you identify what k will be, the y coordinate. 9 can be expressed as 3 squared, and now it's in that form. Okay, my radius is 3, and then my center is HK right there, 1, 0. Okay, so now to sketch the circle, what you want to do is you're just going to go ahead and plot the center first. So we make a dot at 1, 0. And then I'm not expecting to get protractors out or anything like that. The easiest way to get this a rough sketch of this circle is to use this radius to your advantage. Go up 3, go down 3 units from the center, go to the right, go to the left. Get those 4 coordinates going, and then just try to roughly sketch that circle the best you can. Okay, try that for 16. So there's our first coordinate, negative 2, 3. And now we just go 2 units to the right, 2 units up, in those obvious directions, and then we can roughly sketch that circle, okay? All right, so for the circle problems, they get a little bit tougher tomorrow, but for today, we're just going to stick with the basic problems that get you comfortable with that standard form. All right, that's a wrap.